Assalamualaikum, my name is Muhammad of HAZIM. This project focuses on designing a sustainable MVAC system for a two-story residential house. Our goal is to improve indoor air quality and thermal comfort in key areas like the bedroom, kitchen, living room, and bathroom. So we combine technical calculation, actual product selection, and passive cooling strategies to reduce energy use and stay within budget. Next, objective of the study. So the main objective is to propose an energy efficient and environmentally friendly ventilation and air conditioning system. We aim to lower energy consumption and ensure comfort in all spaces. This includes calculating cooling loads, choosing suitable system, and using passive cooling methods. Next, function of the bedroom and kitchen. So the bedroom is a private space where comfort is very important. So it needs proper air conditioning to maintain stable temperatures and good ventilation to ensure fresh air while sleeping. The kitchen, on the other hand, produces heat, smoke, and odors during cooking. So that's why a strong exhaust fan and ventilation system is needed to keep the air clean and reduce humidity. For the next slide, importance of ME system. A well-designed mechanical and electrical system plays a big role in providing comfort and energy efficiency. It helps reduce electricity bills, improves air quality, and supports a sustainable lifestyle. Combining MVAC system with passive design also helps reduce the need for high-energy cooling system. In short, an efficient ME plan adds value and comfort to the home.
Assalamualaikum. My name is Muhammad HEIZRAN Ahmad KAMEL. Today I want to present about mechanical ventilation system in bathroom and kitchen. First, mechanical ventilation system in kitchen. An indispensable kitchen tool, a range hood filter and circulate air and vents it outside the house to eliminate cooking aromas, smoke, oil and steam. Installed right above the stove or stove top, it improves interior air quality and keeps grease off surface by capturing pollutant at their sources. The secondary exhaust fan in the kitchen provides an extra layer ventilation, and secondary fan help handle residual aromas, humidity, and airborne particles that might evade the range hood covering, even though the range hood is made to trap pollutant right above cooking surface. Mechanical ventilation for bathroom. Exhaust fans are made to clear area of airborne pollutant, smell, and excess moisture. Over time, mold development, peeling paint, and even structure damage can result from the high humidity produced by running showers, bathtub, or sinks. Bathroom humidity sensors are cutting-edge gadgets made to automatically check and control the amount of moisture in the air. When humidity level rises above the preset threshold, this sensor measures the amount of the water vapor present and active ventilation equipment, excluding exhaust fan. This is mechanical ventilation system in kitchen and bathroom. In kitchen, we use Elbaf EHO 601XT, while in bathroom we use Panasonic FV20CH9.
Next, we go to our part, the cooling load estimation for the living hall. Is performed to determine the appropriate air condition capacity needed to maintain thermal comfort. This calculation considers several factors that contribute to heat gain within the rooms, which must be offset by the air conditioning system. So the first thing is find the room area load. The living hall has dimension of 6.1 meter in length and 5.1 meter with wide, giving a total floor area of 25.01 square meter. In South Asia, climate's a standard factor of 500 BTU/hour per square meter is used due to high temperature and humidity. So the room area load is 25.01 meter per square multiply 500 BTU per hour, which get 12,505 BTU per hour. Next, we go to equipment loads. There are 5 equipment loads in the living hall. Each person typically add about 600 BTU per hour due to the body head. So the total equipment load is 5% multiply 600 BTU per hour is 3000 BTU per hour. Next, we go to the sunlight orientation loads. The room has a east-facing wall which is exposed to morning sunlight. This contributes additional heat estimate at 10% of the base area load. So, the total of sunlight orientation load is 1250.5 BTU per hour. Next, we go to the equipment loads. There are internal heat source in the room, including a TV and 4 LED. Like the estimate heat gain is which is TV, we got the 400 BTU per hour, LED 4 multiply 100 BTU per hour, and which is we got the 500 BTU per hour. Total equipment load, which is 800 BTU per hour. And lastly, air infiltration load. Normal air infiltration add additional 5% of the base load. So the total of air infiltration load, normal air infiltration, which is 625.25 BTU per hour. So we go to the so the total cooling load, we got 18180.75 BTU per hour. So based on the total cooling load of 18180.75 BTU per hour, the recommended air condition size is approximately 2 horsepower, which typically provide cooling power of around 1800 BTU per hour. This ensures the room is cooled efficiently without overloading the unit or causing discomfort to the efficient capacity. Next, we go to the other slide. So this table shows a summary of the calculation of the estimate cooling load for each room, likely the living room, master bedroom, and bedroom 2. Next, we go to the other slide. So this table shows a summary of the calculation of the estimate cooling load for each room, likely the living room, master bedroom, and bedroom 2. Next, we go to the next slide. So this table shows a comparison between the indoor air conditioner brand HEIZRAN and Daikin for installation in master bedroom. So we recommend the HEIZRAN SAU 2.5 horsepower. It is better because the unit use R32 refrigerant and inverter technology, which reduce power consumption during long operating hour. Designed for bedroom use, the higher operated at a low noise level 28 to 32 dB, making it suitable for restful sleep environment. Next, we go to the comparison and recommendation. This table shows the comparison between HEIZRAN and Daikin indoor air conditioner brand for installation in living room. So we recommend Daikin FTK series 2.0 horsepower. It is because better efficient, more advanced features, and quicker operation. So it is good for the living room.
Okay, Assalamualaikum. Okay, this is the part for passive cooling strategy. That means we have to design our building to get the passive cooling. Okay, the first one is site planning and building orientation. Okay, for optimal, we have to optimize building orientation for we we facing the solar heat with a small amount or small surface of our building, and we also have to maximize our natural ventilation. The second one is to strategic landscaping for shade. It means we have to create natural barrier to block excessive sunlight, such as angsana tree or anything. Okay, the tree have to can direct cooling breeze to our house or our building. Okay, this is the second main point for our passive cooling strategies, which is to optimize our building envelope design. This for roof insulation. Okay, the first one we have to install an aluminum foil, as you can see at the photo, to reflect radiant heat and also to reduce heat transfer. And the second one we have to install mineral wool panel, which have a mean R value 2.5 meter square K over W. The purpose of install mineral wool panel is to reduce heat transfer to our building. Okay, this is also for optimize our building envelope design. That we install the wall insulation. Okay, the first photo is show the insulation core layer which have a migration barrier. That means it can prevent heat transfer between our interior and exterior environment. Okay. The second photo is about install insulation wall panel with a precast panel and which have a core layer insulation. Okay, next we move to the next basic concept here, which is we have to use reflective surface material, which is have a high albedo. Okay, the bright color means the cooler homes. Okay, light color roof and wall reflects sunlight instead of absorbing it. Using color like white, light gray, or pastel help lower the surface temperature and keep heat out of our house. Okay, as you can see at the slide, this is the albedo for asphalt surface. This is lower than the white paint. Means the white paint is more reflect, while the asphalt surface is more absorb the heat. Okay, as you can see at the right photo, the reflection based on albedo value, which is the dark one is absorb 100% of the heat radiant, and then the white one is 100% reflect. Okay, the dark surface produce more heat than light surface when exposed to the same amount of light or radiant energy. Okay, for the next basic cooling strategies, just install external shading device. Okay, we have to use the smart shade like the horizontal, which is a canopy, overhang, and light shelf. Either at the bottom one, bottom photo is a vertical, which is a fin, lower or vertical fin. And the last one at the right photo is a egg crate, which is a combination from the horizontal and vertical. Okay. For the overhang, vertical fin and deep set window help block sunlight from enter our house. Okay, these shading tools are important, especially on the east and west side, and can make a big difference in keep our house cool. Okay, the third main point for our passive cooling strategies is to optimize natural ventilation, which is we have to apply the cross ventilation to our building, our whole house is to strategically placing opening, just have windows, more areas of windows that window opening 10 to 15% for corresponding for our floor. And then the second one is about the stack ventilation, this chimney effect. Okay, what is chimney effect? Chimney effect is about the heat transfer
driven by the buoyancy of warmer, less than air, which rise and create a pressure. That's why we have to put such as ventilation to our top of our building.
Conclusion: our final MVAC design successfully combines both passive and mechanical systems to improve indoor comfort and reduce energy use. So the building layout clearly separates living, service, and private zones across both floors, allowing each space to function efficiently. Air conditioning units and exhaust fans are placed strategically based on calculated ventilation rates and cooling needs. So these systems are fully integrated into the building's layout to ensure good air circulation in key areas such as the bedrooms, kitchens, bathroom, and living room. In addition, passive design strategies like proper window orientation, shading, and thermal insulation in the walls and roof help reduce heat build-up inside the house. This strategy works hand in hand with mechanical systems to lower energy consumption and support a sustainable lifestyle. So overall, the final design presents a well-balanced approach that focuses on comfort, practicality, and sustainability for modern residential living. That's all for me. Thank you.